Hello everyone, this is Rishikesh and I'm going to be your webinar host. In this webinar, we are going to talk about a very important networking aspect of AWS, that is VPC, Virtual Private Cloud. We will begin. Let's have a look at the agenda. We will be looking at what is VPC, introduction to VPC. Now, those of you who are completely fresh to AWS might not catch some of the terminologies that we will talk here, but then I will try to make it as easy as possible. Then within a VPC, we have components like Subnet, CIDR blocks, Subnet masks. So we will be taking a brief overview of that. Apart from subnets, there are many other components of VPC, such as the internet gateway, route tables, the rules in the route table, right? NAT gateway, network address translator gateways. We'll be looking at those also. Difference between a default and non-default VPC. When you open a AWS account, you get a default VPC, right? But then for your customizations, you will create something called non-default VPC. So we will quickly look at the differences between the two. And then finally, we will talk a little bit about direct connect and those kind of aspects. And then we will do a hands-on. I will show you quickly how to create a VPC and how to create different components in the VPC. So let's go ahead. What is VPC? We know that AWS has a global presence. AWS is a cloud service provider company, subsidiary of Amazon. So they are into a business of providing this cloud-based resources to you. Networking is one such service which AWS provides. So on the vast area, global area of AWS, as an organization or as an individual, when you open an AWS account, in the form of VPC, a small area of that AWS account is dedicated to you. Okay, so VPC is a logically isolated network from other virtual networks in the AWS cloud, where you can launch AWS resources. So this is your small area in the global infrastructure of AWS. And now you get separated from all other such global, private networks across the AWS. Okay, so you are free to launch your own components, set up networking, set up security for those components the way you want it. So it gives all the benefits of traditional network that you have for your own data center. So it's like running your own data center. Correct, but the only difference is your data center is physically present in your building or in your premise, whereas this is present virtually for you in AWS cloud. So access the resources and applications through IPv4 and IPv6 in your VPC. We will also understand what is IPv4 and IPv6. These are types of IP addresses that we have today. Gives the benefit of scalable infrastructure in AWS environment. If you have worked with cloud or if you have known cloud, then it is known for the flexibility and scalability, right? Whenever you want a server, you can create it. Whenever you want to increase the number of servers, you can increase it. Whenever you want to decrease it, you can decrease it. So it gives you all of those benefits. You will have complete control over your virtual network, right? Here you will decide what you want to create, what kind of local network areas you want, what are the different parts of your network you want to create, how you want to connect them, what kind of firewalls you want. All of those is decided and customized by you, right? So this is a representation, a diagram representing what VPC is. Okay, so as you can see here, the VPC is tied to a region. Region is a small part of AWS global infrastructure. Again, AWS global infrastructure is divided into regions: Americas, Europe, Asia, and those kind of things, Africa. So when you open an account, you will get a default VPC, okay? So whichever region you select to create your VPC, that VPC will be tied to that particular region. Okay, so VPC is a regional service, right? Now, once you create your VPC, you can see this outer box here. Once you create your VPC, this is your own area to play around in AWS, okay? For companies, they will have their own VPC. And within the VPC now, based on your use cases, based on your requirements, you will go on creating small sections of this VPC. Those are known as your subnets, okay? Now, within the region, at the global infrastructure level, we have regions in AWS, and within regions, we have availability zones. So these are the areas across the globe where AWS have their data centers, physical data centers. Correct? So you can see my VPC is tied to a region, but my subnet is tied to an availability zone. So my subnet exists in one of the data centers in one of the availability zones. So I can have multiple subnets inside a region. Okay. Now, protection can be provided at various levels. This VPC subnet can have its own firewall. This is called as NACL, Network Access Control List, which protects the subnet from unauthorized access. Okay, as you can see, this VPC is connected to the internet. Okay, over the internet, people can access this VPC. Your customers, your clients, your vendors, whatever it is. To get the VPC communicate to the internet, we have something called Internet Gateway. Okay, so Internet Gateway is a point through which your VPC talks to the world. Okay, so you can see your traffic can come within your VPC, and once they are within your VPC, they will go to the subnets. So based on whether you want to keep the components of the subnet private or public, you will place the NACLs around these subnets. So this is an extra layer of security which you have around each of your subnets. These are called NACLs. Okay. Now within the subnet, you will have your components. You will have your resources created. In this case, they have shown an EC2. This is a virtualized server. You can have a database. You can have an EC2 server. You can have your S3 bucket and those kind of things. Everything, whatever is your resource. So you will place those resources within the subnet. Okay. Now, while you're creating the resources, like here in this case, EC2 also has its own firewall at the resource level. That is called security group. Okay. Security group. So whatever comes into the region, filtered, some of that will get filtered and get to your subnet. And from that also, if you want to filter something to reach your EC2, that can also be filtered using the security group. So there is security at every gate in your AWS infrastructure, right? Now you can see, let's say this is my public subnet. I have all my public web servers and everything in this subnet. EC2 instance is, let's say this is a web server that I have provisioned here. And then this web server will talk to a backend server. Let's say this is my database, this EC2 in the other subnet. And this is my private subnet. Okay. So whatever is placed in my private subnet, only access through the VPC. Okay. Nobody from the internet can directly access this database. Obviously, you don't want it, right? You will want people to access your website through this web server. So it is public facing. But this web server might be maintaining a list of users, their credentials in a database. So this web server should be able to access my database, but nobody will be able to directly access my database, right? So we will keep my database server in my private VPC and my web server in my public VPC. Now, how does it become a public? How does one subnet become a public subnet and one subnet, the other one becomes a private subnet? The subnets are same. What makes them private and public is their ability to connect to the internet gateway. Okay. So if my subnet knows the route to go to the internet gateway and to the internet, that is called public subnet. Now, how do I provide a route? I have something called routers. Route tables, correct. Router has route tables. So the subnet, in the route table, we will talk about route tables a little bit later. In the route table, we can provide a range of IP addresses which can communicate to the subnet. Okay. So by default, the routers will have communication routes created by default for the internal entities. Like this subnet can talk to this subnet can talk to this subnet, or anything in the VPC can talk to the subnets. But the route table associated to a particular subnet, even though in this diagram it is shown as one route table talking to one subnet, but then we can have multiple subnets and multiple route table associated with them. Okay. So if this route table associated with the subnet has a route which is pointing towards the internet gateway, that means all the components of that particular subnet can talk to internet through internet gateway, and that becomes a public subnet. Obviously, the private subnet will have everything in the route table associated with it, but it will not have a route going to the internet gateway. So my private subnet components cannot go to the internet, or nothing can come from internet to the private subnet, right? So using subnets, security groups, routers, internet gateway, I can set up my own network, that too in my personal area over the AWS network. That is called your VPC. So let's move on to understanding the benefits of VPC. Access control list is an additional security layer, as we saw across the subnets. Multiple IPv4 can be assigned to your instances. Controls both outbound and inbound traffic of the instances. In VPC, we have something called VPC flow logs, which keeps track of what is coming in, what is going out, right? So those kind of things can be done at the VPC level. Multiple network interfaces can be attached to the EC2 instances. EC2 instance security group membership can be changed while it is running. We know that the firewall at the instance level is called a security group. Static IPv4 assigned to the instances which persist across starts and stop. These are called elastic IP addresses. They can be assigned to this. Create a layered network of resources. You can have a web server talking to the database server, or a database server calling something else, Lambda function. And all of that you can configure to work in a VPC in a very secured manner. Single tenant hardware option is available. If you select dedicated option for your EC2 instances, then entire VPC will exist on one physical server, only used by your company in the AWS cloud. Otherwise, it will be shared. The IP for private network would access what in public web services, as an example. The IP private network would access what in the public server. Yeah, I gave an example on the previous slide here. Let's say this is my public subnet, right? And this is my private subnet. In a private subnet, my database is sitting. The machine on which my database is sitting has an IP address. So this web server can access the IP address of this database server. So it can access it internally. But nobody knows about the IP address of this database server. They cannot access it from outside, right? So internally, they can access each other's IP address. And the IP address ranges are provided using CIDR blocks. We will be talking about that in a while. We have just started scratching the area of VPC. Okay, so I talked about a default VPC. Default VPC is the VPC which gets created for you when you open an account on AWS. By default, there will be one VPC created. Okay, now the internet gateway, subnets, route tables, everything gets created by default for you, right? So even if you don't know anything about the networking, you can start using it. In that case, everything is set up and managed by AWS. You do not have any customizations around it. From public services, they can directly get values from DB. Yes, that's how it should be, right? Let's say on a public web server, you have a table. So my user clicks and looks at the number of students enrolled in a course, right? And that is maintained in the database. So they cannot directly go and fire a SQL statement on the database. But from the web server, through some interface, they can query in a tabular form. It will show them the value sitting in the database. So they are not directly accessing the database. They will have to go through the web server. In the web server, they might get authenticated and those kind of things. So only authorized people are seeing values in the web server, not getting directly to the database. They cannot insert records in the database. Those kind of things can be achieved. So the default VPC is created on your Amazon account creation. While creating EC2 instances, by default, it chooses the default VPC. Because it is available by default, whatever you do in your AWS infrastructure, it will be created in the default VPC. Each availability zone will have one default VPC. Okay. All advanced features are provided by EC2 VPC are configured for default VPC. So whatever we saw on the previous diagram, the the internet gateway, subnets, route tables, everything is available in the default VPC as well. But the difference here is it is created by default. You did not configure anything for it. But in case if you want to provide or have customizations for you, the number of subnets that you want to create, the kind of route table rules you want to set, then you will create your own VPC. Okay, that is called your non-default VPC. When you create your non-default VPC, you have to set up everything from scratch. You have to create your own gateway, internet gateway, attach it to your newly created VPC. Otherwise, your newly created VPC will not be able to talk to internet. So if you don't want to do all of that, and if you don't know how to do that, then you will use default VPC. Okay. In the production environment, generally you will be using non-default VPC that you will create. So what are the different components of VPC? You have internet gateway, then you have your NAT gateways, elastic IP addresses, VPC endpoints, network interfaces for different components in the VPC. Then you have your route tables, and you have something called VPC peering also. What is VPC peering? When one VPC talks to another VPC. Okay, it's like a wormhole between two universes or two galaxies. Correct? So let's say my company has one VPC and my vendor company has another VPC. For some reason, I need to access some of the servers from that VPC. Then I create a connection called VPC peering. Now, these are all advanced concepts. We might not be able to ponder more on that or do a demo on that, but definitely we'll try to do some basic demos. Okay, let's go ahead. So while creating a VPC, the first step is to assign the IP addresses. It's very important because we're talking about a network area, and in the network, everything gets identified by what? IP addresses. So IP addresses are the unique logical numerical labels assigned to each device in the network. So who is internal to the VPC, who is external to the VPC, everything gets decided by the IP addresses. Whatever is internal to the VPC, if they're talking to each other, my private web server, database server is getting contacted by the public web server. How are they contacting each other? These are machines, right? So they know only about IP addresses. So we all must be knowing about IP addresses, I'm assuming. So 176.57.68.0.0/19 is your IP address. /19 is a subnet mask. Okay. Depending on what is after slash, you will be reserving certain ranges of IP addresses. We will talk about the CIDR blocks in a while. You will understand that. So what is CIDR block? CIDR, classless interdomain routing. So these are set of IP addresses which are reserved for your VPC or for your subnets, through which different components will talk to each other. So CIDR is a way of allocating IP addresses more flexibly over the number of bits used for the network part. Makes blocks of address assignable. So it reserves certain ranges of IP addresses for subnet or VPC. Allows in granular way of assigning block addresses to organizations. So how does a CIDR block look? It looks like this. 172.31.0.0/16 is your CIDR block. Now, depending on what is after the slash, if it is 16, then it is reserving 65,000 plus IP addresses. Generally, you will do /16 subnet mask for VPC. Within the VPC, when you have subnets, within the subnets, you might want 256 IP addresses reserved. So that number changes to 24. Okay. And it has 4 octets in it. You can see these are 4 octets. The first 2 octets are network ID and the other are host IDs. So every machine in your VPC or subnet will have the CIDR block range associated with that. Okay. We will create that in a demo. So examples of IP addresses, as I said, machines identify each other using the IP addresses. There are 2 types of IP addresses, that is IPv4 access, IPv4 addresses, and IPv6 addresses. Now, we are slowly getting to IPv6 because when internet came up, they did not think about the number of people who will be using it, the number of IP addresses which will be required. So they had IPv4 addresses. IPv4 is a 32-bit address. /16 represents a subnet mask, as we know. So which means that first 2 octets are locked down to be used as a network ID, and the other octets are for the host ID. Total number of available addresses are 2⁻16, that is 64K addresses will be available for usage. Okay. Now, as more and more people, as more and more instruments are coming into the internet, we are fearing that IPv4 addresses will be inadequate in number to cater to all the machines on the internet. So we have come up with something called IPv6. Now also we are using IPv4. It has not replaced IPv4, but then at some point in the future, we will exhaust and then we will need to use IPv6. So IPv6 addresses are the public addresses with 128-bit, right? Obviously 2⁻128. There are so many other number of IP addresses I can use, right? The addresses are given by Amazon Global Unicast Addresses, GUA. So they are picked up internally and assigned to my resources. Addresses are allocated automatically from the pool of IPv6 addresses. IPv6 addresses are not that flexible as we have IPv4. So my IPv4 address will look like this, 172.31.0.0. We know all of these, right? Most of us use these. But if you're using IPv6, then it looks like this. This is the IPv6 address. Right? It is not very user-friendly, maybe because we are not using it that much as of now. Okay. So now, once we have the VPC, we talked about the subnets, right? The private subnet and the public subnet. So the public subnet, generally in the production environments, let's say I am a company called ABC. In the company ABC, there are different departments, HR department, finance department, IT department. Each department will create its own subnet. And those subnets will have its own resources inside. So VPC will have certain CIDR block. So you can see here 172.31.0.0/16 is the number of IP addresses in this VPC. Now within this range, we will create two parts. You can see 172.31.1.0/24. So in this range, it will reserve 256 IP addresses. And here 172.31.2.0/24, it will reserve again 256 IP addresses. And all the resources sitting here will have it in this range. Marketing team, technical team, or whatever, right? So it is a portion of network that shares a common address component. Subnets are within the region, within the VPC. All devices whose IP addresses have the same prefix are in the same subnet. So you can see here 172.31.1 will be part of this subnet. 172.31.2 will be part of this subnet. Okay. What is a subnet mask? The number that you see after this slash is nothing but your subnet mask. So it decides how many IP addresses will be here in this range. 16 stands for 64,000 plus IP addresses. 24 stands for 256 IP addresses. So when I say I have a VPC with this range, so in the 65,000 IP addresses which are reserved for this VPC, I can have small sections, small chunks of 256 addresses given to each subnet. I can have multiple subnets. Correct? So that is your subnet mask. Now, let's have a look at the difference between IPv4 and IPv6 IP addresses. Requires for IPv4 required for all VPCs cannot be removed. Okay, whereas IPv6 we can choose. IPv4 is by default given to us. IPv6 is, if I want to use IPv6 IP addresses, I can choose that. You can opt in only. You have the option of choosing the private IPv4 addresses for your VPC. Whereas when you select IPv6 arrangement, you cannot select your own range. It is given automatically. I don't have any control over that. So people prefer IPv4. CIDR block size should be between 16 and 28. Here it should be 56. It is fixed at 56. Subnet CIDR block size can be 16 to 28. This is for the VPC and this is for the subnet. Subnet CIDR block size is fixed at 64. So you can see a lot of control is lost when we go for IPv6. All instance types supported IPv4, but there are certain instance types like C3, R3. Now, to understand these instance types, you should know AWS a little bit, compute part of AWS, which is not in scope for this discussion. But these are EC2 instance family type. They only support IPv6. So it's a very limited usage as of now. Elastic IPv4 are supported. Elastic IPv6 is not supported. This is something to talk about. Elastic IP addresses. The static IP addresses, these are all IPv4 addresses. IPv6 addresses cannot be static. Okay. So we have already talked about what is private subnet and public subnet. One thing to remember about this is private subnet is something which doesn't have a route to the internet gateway, and it cannot talk to the internet through internet gateway. It can only communicate internally. Whereas public subnet is the subnet which is attached to a route table which has a route going to the internet gateway and hence to the internet. Now let's talk about the internet gateway. A component in VPC that helps to communicate between the instance and the internet by providing the targets in the route table. Okay, when we create an when we create a non-default VPC, we have to create the internet gateway for our VPC. By default, it is not assigned. So when you create an internet gateway, manually you have to assign it to our VPC. When you are using default VPC, this is all taken care by AWS. You do not have to separately create internet gateway, right? But if there is no internet gateway, your VPC will not be able to talk to the internet. How does it talk to the internet? Your route table associated with that subnet will have a route going to the internet. In the demo, we will see how to set that up. Route tables, as you can see while I'm talking, route tables become a very important component because, as the name suggests, they have rules and routes in them directing communication between the different components within the VPC and out to the internet. Correct? It looks something like this. So you can see here, if I'm saying destination is 172.31.0.0/16, that means everything within this VPC. This is a internet IP address range. Within this VPC, will have IP address within this range. So it is a local, target is local. So with this entry, all the internal components of my VPC across the subnets will be able to talk to each other. If this entry is also removed, nobody can talk to each other. Now, when I want this particular route table to have a route to the internet, I will have this. As we are talking about internet, we don't know what the IP range is, right? So 0.0.0.0/0 is an IP range, infinite IP range on internet. Then if it has to happen, if the communication has to go to the internet, this type of traffic request, destination is internet, then the target is internet gateway. You should have this entry in the route table. And when this route table is associated to some subnet, you can see subnet association, that subnet becomes public subnet, and everything within that subnet becomes publicly accessible over the internet. Opposite of this is your private route table. Each subnet has to be associated with the route table. We know that your VPC comes with an implicit route table. When you create a VPC, there is a default route table also. Okay, but then we can create new route table. No matter how many route tables we create, we cannot delete the default route table associated with the VPC. You can create your own route tables, but cannot delete the default one. You'll have to keep it, use it or don't use it. You cannot delete it. Okay. Now we have something called NACL. We have already seen in the diagram, there are firewalls provided at the interface level, at the resource level, which is called security group. And there are firewalls provided at the subnet level. Okay. Now, both of these are firewalls, but then security group is at the instance level. It is a stateful interface. It is a stateful firewall. That means if you allow something to come in, it is also allowed to go out. Same type of traffic to the same destination, right? It acts as a firewall. You can create up to 500 security groups. One single instance can have multiple security groups. Okay, one security group can be assigned to multiple instances as well. In the security group, you can put only allow rules. You cannot deny anything. Denial is not allowed in the security group. Correct? So this is what it looks like. Inbound traffic, security group ID, protocol all, port range all, allow. So if it is coming from, if I say this is my security group entry, that means I'm allowing everything from the internet to come in. And this is for the IPv6 range. Okay. As opposed to that, we have the network ACLs. We also call it as ACLs, access control list. This is at the subnet level. Okay, so you have one more additional level at the subnet level. If you want to filter out whatever is coming to region, if you want to further filter out to enter in the subnet, you can have an NACL attached to that. One NACL can be attached to multiple subnets. Now in the NACL, you can have allow rules as well as deny rules. Also, ACLs are stateless. That means if you have an inbound traffic allowed in the ACL, you need to explicitly define the same type of traffic going outbound, unlike security group. right? In security group, if you define inbound, outbound is already created automatically. But here you have to explicitly create it separately. You can allow and deny both types of rules here. Okay. And the rules are executed in the sequence, in the ascending sequence. So rule number 1, 2 will be executed in sequence, and then it will be applied to the traffic coming in. So again, briefly summarizing the differences between NACL and security group. NACL is stateless. Security group is stateful. We have already spoken what is stateless and stateful is. Defined per subnet, NACL. Security group is defined per resource. NACL can define both allow and deny. Security group can have only deny. A subnet can be assigned only one NACL, and if not associate explicitly, would be associate implicitly with the default NACL. An instance can be assigned to 5 different security groups. Okay, but there can be only one NACL. But one NACL can be assigned to multiple subnets, but one subnet can have only one NACL. Okay, just remember that. Now there is one more concept here called NAT. NAT stands for Network Address Translation. What is it translating? What address is it translating? As we know, in the private subnet, we have components which are supposed to be kept private. Let's say some server is private. So I do not expose the IP address to the public, to the internet. So it has only private IP address. Okay. So I'm good here, right? Now this instance is protected. Nobody knows about its public IP address. But this becomes a problem when my server, let's say, needs to access internet from within the VPC. That means my server needs to access the internet, not internet accessing the server. Right? Because the server doesn't have a public interface, network interface, it cannot talk to internet. Correct? So in such scenarios where I want to have only outbound traffic going from my subnet to the internet and not internet to subnet, I have something called NAT gateways. Okay, so NAT devices. NAT devices are of 2 types, NAT gateway and NAT instance. NAT gateway, the functionality is same. The only difference is NAT gateway is managed by AWS and they are very highly available, high performant and those kind of things, cost less. Whereas NAT instance is when I want to set up my NAT gateway, my NAT device on my own. I might have a third party, some kind of an application, and I want to set it up on the EC2 instance. So I have to manage everything. It is not as highly available as AWS's NAT gateway. It is costly also. So most of the times you will be selecting NAT gateways only because AWS will take care of it. Right? So how does NAT gateway work? As I said, when you have a NAT gateway, in the route table of your private subnet, you will have an entry going to the internet, that is 0.0.0/0. And then instead of having it going to the internet gateway, I will have it going to the NAT gateway. Okay, NAT gateways are placed in the public subnet. So from there, it can access the internet. So now here, my components of my private subnet are indirectly accessing the internet using the NAT gateway. Right? But then this is only outbound traffic. Nothing can come back from the internet to my private subnet. So my private subnets are still private subnet and private subnet components are still protected from the outside world, but they can access the outside world. One-way traffic is allowed, right? So it's the same thing is done by NAT instances. So I have summarized this difference between the NAT gateway and NAT instance. You can go through that later. And then finally, we have the VPC peering concept. When I want 2 VPCs to talk to each other, now these VPCs might be different companies' VPCs or different account VPCs within one company, different regions, or things like that, right? Outbound to which IP? Outbound to internet, 0.0.0.0/ outbound to anything. Because when I say outbound towards the internet, I don't know what all IP addresses exist on internet, right? And that's why the outbound traffic, the destination is 0.0.0.0/0. Okay, so VPC peering. VPC peering is a term used for the communication between, but example, Ravi, the example is 0.0.0.0/0. That is the IP. You do not specify any particular IP. Sending data to whom? I mean, you might be accessing google.com. Let's say you want to download some patch for that server from google.com or microsoft.com. So those IP addresses are the destination for that kind of traffic. Right? So VPC peering will allow two VPCs to talk to each other. Now, this is a three-step process. First of all, this VPC, there is a requester VPC and requested VPC. So requester VPC will need to request a peering request to the requested VPC. Right? Once it is set up, my requested VPC will accept that peering request. Okay, the administrator of that VPC will accept that peering request. And once the request is accepted, then the route tables of both the VPCs will be updated with the rules to allow the communication from the IP ranges of this VPC to this VPC. Now, the only restriction here you can see in the ranges also in the CIDR block, the CIDR block should not be overlapping. Right? If there are same, that means it is overlapping CIDR block. It doesn't allow the peering between such VPCs, because then it will get confused which IP is from which IP address. So the CIDR block ranges should be different. Okay, completely different. So we will do a quick demo, guys. So let me just take you to the console here, and I will quickly create a VPC. So when you go to the console here to create a VPC, you can see by default, there is one VPC already present. This is a default VPC, which is available to you. I can go ahead and create a VPC. I'm creating only VPC. Let's call this VPC as my VPC. Okay, you can see IPv4 CIDR blocks. So for this VPC, the CIDR block which I'm giving is 10.0.0.0/16. We know what it is by now. So it will reserve 65,000 plus IP addresses. No IPv6 CIDR blocks. I don't want that. Tennessee is default, and I will say create a VPC. Okay, so this is my VPC created now. My VPC is my own VPC. Generally, in the production environments, you will begin the networking and setting up your cluster by setting your VPC first of all. Now, within the VPC, if I click here, you will see these are the subnets, but then these are not my VPC subnet. These are the subnets associated with the default VPC. The number of subnets which are available will depend on the region. In the North Virginia region, when I create a VPC, I have 6 availability zones in North Virginia region. So I will have one subnet for every availability zone. If you're in Mumbai region, then there will be only 2 subnets or 3 subnets. Okay. Now in my VPC, I will explicitly have to create all of those components which we discussed. So the very first component that I'll create is Internet Gateway. I need my VPC to communicate to the internet. So I will create an Internet Gateway. By default, there is an Internet Gateway, but this is available to the default VPC. For my VPC, I will create an Internet Gateway. I will name this as my Internet Gateway. That's nothing, no other setting in the Internet Gateway. Create an Internet Gateway. Once the gateway is created, I need to attach it to the VPC. Because without this, my VPC is not visible. Attach it to my VPC. Attach the Internet Gateway. Correct? So now my VPC is equipped to have a communication to the internet. In the VPC, then I will go ahead and create subnets. Okay, create a subnet. Where am I creating the subnets? I'm creating them in my VPC that I've just created. Okay, now subnets are tied to availability zone. So I can create a subnet. Let's say this, I call it as public subnet, pub/sub, and the availability zone, let's say in the first availability zone. That means in some data center, the subnet will be created. IP ranges 10.0.1.0/24. It will reserve 256 IP addresses for this subnet, which should be in the range of my VPC's IP range. Correct? This range comes between the VPC's range. Create the subnet. I will create one more subnet, same VPC, and then I call it as private sub, pri/sub. And I will create it in a different availability zone, let's say US East 1B. The range for this should be 0.2.0/24. Create the subnet. Okay. So my subnet is created, my VPC is created, my Internet Gateway is created, but now I need to have a route table. Let's create a route table. If you can see, I have a default route table for every VPC, for the default VPC and for my VPC here. You can see this is my VPC's route table. Okay, I can keep this one. I cannot delete this one. I can create a separate route table though. So let's call this as a pub RT, public route table in my VPC. That's it. Created. While creating, you don't mention anything. But after creating, I need to first of all associate a subnet to this route table. Okay, edit subnet association. Because this is a public route table, I will associate my public subnet to this route table. Okay, my association has happened, but my routes are still not set. So if you see by default, it has everything locally allowed to talk to each other. This is local. But because my public subnet is supposed to access the internet, to be accessible from the internet, I need to edit the route and add one more route here. That is 0.0.0. This is for everything on the internet. And when my route table, when my subnet wants to access the internet, it should take help of what? Internet gateway. I have just created this internet gateway. Select this one. Save changes. Okay, now let's go back and see our private route table. Where is my private route table? Where are my route tables? My other route table doesn't seem to have been created as yet. It will take some time. Okay, this is my subnets. Route tables. Did I not give the name? Okay, I didn't give the name to this route table, is it? Okay, so let me just give it private RT. Okay, so this is my private route table. You can see for the public route table, we have already associated a subnet, which is my public subnet. Now we will go to this route table, associate a subnet. Obviously, we will be associating the private subnet to this. And now if you look at the routes here, it is allowing the local entities to talk to each other through this route. And because I want to keep it private, I will not add any route to the internet gateway. The very fact that I do not have any route telling the subnet how to go to the internet gateway makes this route table as a private route table, and whatever subnet it is associated to, that subnet becomes a private subnet. Okay. Now this is done. My components are set up. Now what I need to do is set up EC2 instances in my subnets. Let's go ahead and create EC2 instances here. I will create Windows EC2 instances. That becomes easy for a demonstration. So let's call this as a server 1 is my public server. We will create a Windows machine. We will select a T2 micro. Everything will be same. And let's call this as demo key 1. And networking, I want it to be in my VPC. I want it to be in the public subnet. And I want the IP address, public IP address to be enabled because I'll be accessing it over the internet. Create security group, fine. Because this is a Windows server, I will have RDP protocol accessing this. So I'm allowing that here. And rest of the things we can keep as it is, launch the instance. In the meanwhile, I will launch one more instance. Let's call this as server 2. Let's say this is my private web server or private server or a database server for that matter. This is also Windows server. T2 micro, same key value pair, DOM key 1. And I will again put it in my VPC. This time I will put it in my private subnet. And because this is a private server, I will not give it any public IP address. So I will keep it disabled. I can use the same security group that I have created earlier. That is select existing security group. And I will take this one, launch wizard 1. And I will create this instance. Okay. So now my instances are ready. I want to access server 1. Let's say I'm a client to this particular website. I want to access their public web server. So I will go here, pick up the public IP address, go to the remote desktop application and provide this IP address here. Connect. it will ask me for the user and password. What is the user and password for this machine? If you go to connect here, RDP client, you will see username is administrator. Put this here. And password. Get password. I will need to decrypt my password. Connect. Okay. While the machine is coming up, it might give you. Okay. Get password. I will have to upload my private key. What was my private key? The private key was, what was the private key? It was demo key 1, right? So maybe in the downloads. Yeah, this is the private key I have. Decrypt password, get the password, and access it. Okay. So this is my remote access for that server running in my VPC in the public subnet. Okay. Now let us go to the console once again and look at this instance, which is my private instance, server 2. If you look at the details of this, there is no public IP address. So I cannot access this server from the internet directly. What I'll need to do is I will have the private IP address of this machine, accept it, copy it. And now I cannot directly access it from the outside world, but then I can access it within this server. Okay. While this Windows server is coming up, what I can do, I can open another remote desktop connection from this server within the server. And from there, I can access that private server. Now let the server come up. Okay. If I go to the server and invoke remote desktop from within server. Okay. I'm not doing it from my machine. I'm doing it in the remote machine. This might be a little bit slow because we have taken T2 micro, which is very slow server. So it might take a little bit of time. Let's invoke this here. Okay, this is my public server. You can see the details here, public IP address and all. Now within the server, I'm starting remote connection. It will come up in a bit. That's a problem. This becomes very slow. Remote connection. Right here, I will give the private IP address of that instance, which is my private Windows server. Okay, administrator. Now, if I go to the credentials of this machine, if I click on connect here, RDP client, this is my private server. Okay, this is administrator. And for this server also, I will have to get the password using the same process, upload the private key, decrypt password, get the password, and access it. Now you can see from my public server, which is my outside server, I am accessing the private server. This is actually the private Windows server. I'm accessing a Windows server within a Windows server. I could not do this directly from the internet because this is my private web server, right? So using these components of VPC, I can actually set up the entire network within VPC. So this is my private server, the internal window, and this is my public server, the external window. Okay, so you can see if I try to access google.com from the outer server using any web browser, I will be able to access. Within the internal server though, the private server, if I try to access internet with this setting, it will not allow me to do that, right? And that's why we have discussed the NAT gateway. Okay, I will create one NAT gateway. I will update the route table, and then I can access internet from this private server as well. With that, it brings me to the end of this session, guys. Have a wonderful day ahead. Bye-bye.